Good morning, everyone. It's my great pleasure to give the presentation as a brain workshop. My name is Tianyu Li, and today our topic is about decentralized private freight declaration and tracking with data validation. First, let's see a recent news from the website. The Dutch customs says cocaine was estimated 225 million euros from Banana, Peru. It's amazing money. Actually, the drugs are hidden in a container shipped from Ecuador and destined for Basel. The Netherlands has become a major conduit for drugs, especially for cocaine into Europe. This is a big problem, and it's very common. So what are the reasons? Here we have lifted 2 points. The first is that customs agencies receive unverified data. There is always a large shipping manifest, and also, if there is a problem, the customs agency needs to trace through third party to know where is the problem is. For the second point, customs agencies also want to use the unverified data to make risk analysis decisions to know whether there is any smuggled goods in the container or whether the container is declared properly. So, before moving to the existing solutions, we want to first mention the assumptions for this question. The first assumption is that operators trust their own country's customs agency. For example, if a ship from the Netherlands wants to transport packages to other countries, they need to trust their own country's customs agency, the Dutch customs agency here. The second assumption is that customs agencies do not trust customs outside their trade bloc, because they don't know whether they are trustful or not. For assumption 3 is about packages in the system may only move by shipping container. This means that the packages can only be transported in a container instead of in a box or in any other things. And the final point is that the route packages take to their destination is unknown beforehand. Based on the assumptions, the defense system is proposed in 2018. In the proposed system, there are 2 different roles: the customs agencies and economic operators. The economic operator is about the container handler to transport the packages. And they can make 2 different claims. The package claim is about how the package is inserted or removed, like operator A has put package Y into container X. For the other claim, the container claim, is to show when the containers are transferred. Operator B can say that they have shipped container X to operator C. And similarly, operator C will say that they have received container X from operator B. Note that here, only the receiving customs agency can read package claims. Although the defense system is proposed, there are some shortcomings. The first one is that the system is with limited validation capabilities. The system only offers 2 claims, and the container claim can be validated for the double spending, and that's all. The second point is that they show some operations, but they didn't detail the cryptographic tools. For example, they show that only the receiving customs agency can know the package claims, but they don't show how. The final point is that the proposed system only model with customs agencies and economic operators. They didn't care about the whole structure of the transportation, and only 2 roles in the system. Knowing the shortcomings, we propose our current system. from the seller to the buyer. Here we have the logistic operators. The seller gave his package to the logistic operator and they sent it to the buyer. However, they didn't cover all the transportation process. There are container carriers to carry out the containers in the middle. Note that here, the train or the ship, which are the carriers, they may contain a lot of containers from different logistic operators. Finally, it's the custom agency and check whether the containers are legal or not. Based on the design, we model the gray area from the logistic operator, the container carriers, and the custom agencies in the private blockchain to share information among each other. And seller and buyer, they don't have access to the blockchain, so they cannot get any sensitive information from it. Okay, based on the design, we can make some comparisons between our design and the previous defend design. So in the defend, they only have the economic operators to make two different claims, the package claim and the container claim. The container claims can be used to avoid double spending. Here, in our current design, we have separated the economic operators to two different actors, the logistic operators and the container carriers. The logistic operators put the package into the containers, so they can make the package claims. For the container carriers, they transfer the containers among different carriers, so they can make the container claims to avoid double spending. To be more specific, here we have changed the container claims to the transfer claims. Also, we have added the location claims to show the location of a container. Also, the location claim is validated based on the ownership of a container. For example, only one carrier can show the location of a specific container, and the other carriers cannot. Besides, we have added another claim called identity claims from custom agencies. We applied key restoration and revocation through custom agencies to allow participants to verify the authenticity of claims made to the blockchain. Here, we will show the identity claims in more details. Assume that we have party P. It chooses secret key and uses it to compute the public keys. Then, we can show the identity claims based on the roles. If the party is a custom agency, it makes an identity claim for itself because a custom agency is trustful. The claim includes the public key, the working name, and the identifier. However, if the party is an operator, it relays public key to its trusted custom agency. The trusted custom agency makes an identity claim on behalf of the operator. The claim includes the public key, the operator's working name and identifier, and the custom agency's working name and identifier. Then, with the claim, the agency signs the entire claim with its secret key to show that this claim is verified by this custom agency. After seeing the identity claims, let's move to the functionalities. About the container and package tracking. From the side of the custom agency, they can track the route of the container. Also, because the use of the blockchain, data arrives as soon as it is published, and the data is validated by all other actors. From the side of the buyer, they can also track the route of the packages. The buyers can ask the logistic operator for the package ID, and the logistic operator knows the corresponding container ID for this package. Then, they can use the location claims to find the location of the package and share it to the buyer. Besides the package and container tracking, another functionality that our proposed system can provide is that both the parties can read back from the blockchain to know the history of the claims. For example, the operator shared the claim with the custom agency, and if we use the public key encryption scheme, Alice has the public key of Bob, and she used the public key to encrypt the message and store it in the blockchain. However, here, only Bob has a secret key to decrypt the data and get the accurate message M, but for Alice, she can never read back the message because she didn't have the secret key and decrypt the block again. So, now the requirement is that the parties must hold a history of their claims, and actually the public key encryption scheme cannot satisfy. So here we have played a nice trick to make it happen. We assume that both Alice and Bob have a key pairs for the public key Alice, secret key Alice, and the same for Bob. Then Alice used the secret key of Alice and the public key of Bob to generate a symmetric key for AES and use the symmetric key to encrypt the message. What's interesting here is that if Bob uses his own secret key and the public key of Alice, he can generate the same symmetric key for the AES encryption. So, Bob can use the generated symmetric key to decrypt the block to get the message. As a result, both Alice and Bob can use their keys to decrypt the data and know the history of the claims. In conclusion, our paper contributes as follows. Firstly, we allow for container and package tracking using the location claims. Meanwhile, we provide cryptographic tools to preserve confidentiality of data in the blockchain. Secondly, we model the entire supply chain from seller to buyer, including several characters, such as the logistic operator, the container carrier, and the custom agency. Thirdly, we register identities on the blockchain using the key generation scheme. And finally, we use the tricks to allow parties to run a lightweight client. Compared to the existing work defined, our new solution is with more validation capabilities. We have modeled more complete supply chain, and we also have provided more functionalities. That's all for my presentation. Thanks for your attention.